we'll see some, flip-flop questions, and then we'll proceed with counters.
There are 2 more configurations are left for shift registers.
Okay, then first we'll continue theory, then we will see the problems. Okay, so we had seen yesterday shift registers. Okay, so in that we had seen first one was serial input, serial output. Second one we had seen serial input, parallel output. Third we will see parallel input, parallel output, and fourth we'll see parallel input, serial output. Okay, so let's talk about the third one. Oh no, why it doesn't start? So we'll talk about parallel input, parallel output. Okay, so in that case, what will happen is, suppose we have the flip-flop. All of them are, edge trigger. It can be any triggering, so you don't worry about this. Okay, it is just a clocking method. That's it. What I'm saying is parallel input. It means all the, see, this is my, let's say D3, Q3, Q3 bar, D2, Q2, Q2 bar, then D1, Q1, Q1 bar, and D0, Q0, Q0 bar. So this will be your LSB, and this will be your MSB. Okay, means most significant bit. Now let us say we have 4 inputs. Okay, and what I will be doing is I'll take the output parallelly. Okay, it will not be serial at all. So suppose we are feeding the inputs, let's say 1 0 1 1. Okay, so what will happen? All the 4 flip-flops will be loaded with the bits. So most significant bit will be loaded here, then 0 will be loaded here, 1 will be loaded here, and 1 will be loaded here. That's all. Okay, so as you can see, what is happening here, that parallel input, parallel output configuration has 4 input. Like for 4-bit, it is 4 input. Okay, 4 input and 4 output terminal for 4-bit configuration. Okay, next is to store. What do we need? We need only 1 clock pulse. Like at least, as soon as it starts, gives a clock, immediately all of them will be stored, isn't it? Because all of them is loaded parallelly. So to store, we need 1 clock pulse, and to retrieve, we need 1 clock pulse. Okay. Sorry. So what I was saying is, see, as soon as you give, yesterday I think you had seen very clearly that whatever the bits that you have stored here, okay, so that will be actually available after 1 clock pulse, but they are already available at the output also, because data like flip-flop gives them at the output itself. So you don't need any clock to actually retrieve them. Okay, so you need 0 clock pulse to retrieve them. So total number of clock that is required will be one clock pulse. Okay. Next is we will see parallel input and serial output last one. Parallel input, serial output. Okay. So what do we need? We need let's say 4-bit again. So we need 4 flip-flops, and we need to have, let's say, clock to all of them. Okay, so clock to all of them. Now, what do we need is, let's say, D3, Q3, D2, Q2, D1, Q1, and D0, Q0. Okay, now all of them are having parallel input and serial output. That's the problem, right? So what shall we do? If we are going to give parallel input, okay, then the problem is if you give parallel input here also, then serially how it will get converted? Serially Q3 must get connected to D2, right? But if you give parallel input like this and then you give like this, then there will be a problem, isn't it? So instead of that, what we'll do is we have a studied multiplexer. Okay, so multiplexer I will use here. So 2x1 multiplexer I will use, and this will be used here. And this guy, the output will be given here. Okay. So similarly, one more multiplexer will be used here, and this is the input. One more multiplexer will be used here, and this is the input. Okay. So this 2x1 multiplexer, 2x1 mux, okay, will be used. Now, these are the inputs. Let's say we are going to give a input 1 0 1. So how the inputs will be loaded? 1 0 1 1. So parallelly all are loaded together. Now the thing is, to select the first, like let's say this is I naught I1, I naught I1, I naught I. So to select I naught, what do we need? We need to have a select line as well, right? So let's say we have a select line. Okay, and this select line is connected to the mux. Okay, so let's say select line is 0. Then what will happen? All the bits are loaded together, because select line 0 means it will be, first bit will be like selected to the mux. So mux has immediately selected 0 and given it to the data. Immediately selected 1, given it to the data. Immediately selected 1, given it to the data. Okay, so like that, all of them have been loaded very easily. Got it? Now, once you make your select line 1, then what will happen? As soon as you make the select line 1, this 1 would have been loaded to the data. That would have come to Q3. This Q3 will send the data to D2, right? If select line has become 1, so next data will be selected and it will go here. So like that, it will proceed. So I don't know, not sure like whether Mahita is able to understand this, because I think she has missed out all mux, demux, everything. Okay. Are you able to follow, Mahita?
Yes, sir, I'm able to follow. I have seen the recording sessions.
Okay, so all right. So this mux has like worked out like that. So to retrieve the data, you have to make select line 1, and to load the data, you have to make select line 0. That's all. Okay. So what we discussed here is, you can write it down in parallel input serial output configuration. Has 4 inputs and 1 output terminal. Okay, because only 1 output we have here. This is the only one which will be giving the data one by one output terminal. Next, to store, we need How many? One clock pulse. Because only one clock pulse is required to store all of the data, the black ones, 1, 0, 1, 1. But to retrieve, what do we need? This first bit will be available here as soon as it is loaded, right? So next 3 more bits are required. So n-1 bit is required, okay? So to retrieve, we need n-1 clock pulse, okay? So total clock pulse is equal to n-1 plus n-1, that is n clocks. So this is actually a great question. All the 4 configuration, you try to understand how you can find out the number of clocks to store n bits, okay? So because that is actually, being asked so many times, okay? Now, one more thing that we had added here is for n-, for n bit configuration, we need n-1 mux required, okay? And mux is needed as selection is required, okay? So mux is needed for the selection, okay? So to store, what do we need? Select will be 0. To retrieve, select will become 1. That's all. That's what we discussed just now. Select should become 1 for retrieval, and the select should become 0 for store. Okay. That's it. Now let us talk about how we can do something different. Let's see a question, okay? Then it will be clear. That is done?
Yes, sir.
Okay, so the question is, we have, we have 4 bits, okay? We have 4 flip-flops. 1, 2, and 4. Okay. So we have here like this. So this is my, P0, P1, P2, P3. This is my D3, Q3, D2, Q2, D1, Q1, and D0, Q2. Okay. We have the clock pulse as usual. Okay. Now we have serial input given like this. Serially, it is being given. And the output is taken parallelly. This is my Y3, Y2, Y1, and Y0. Okay, that's all. So you write down the question. Assume the initial condition for all flip-flops are 0. Okay, in the above universal shift register, shift register, this is the thing. This is the thing. This can be utilized as all the 4 configuration. Okay, why it is called universal shift register is, see, I didn't tell you this one, this enable line and all. I didn't tell you. Okay, priority kind of thing. So this is called universal shift register because as all 4 configurations are there in this, okay? Like serial input, serial output, serial input, parallel output, parallel input, parallel output, parallel input, serial output, okay? Now, all flip-flops are initialized to 0, 0, 0, 0, okay? If it has to be used in parallel input serial output mode, okay, then to store a 4-bit number or binary number, you can write how many clock are needed. Hello. Yes, ma'am. Yes, ma'am. Yes, ma'am. Okay, sorry. So how many clock are required? That's it. That is the question. Okay. Tell me how many clocks are required? See what will happen. Let us consider any number, any digit like 1011 that we have to store in this. So what it is saying that if all flip-flops are initialized to 0, means all of them are having 0, 0, 0, 0 as the output. Okay. Now the aim is yeah, yes, ma'am. Yes, analog electronics is one subject, digital electronics is another subject. 2 subjects are. All right, ma'am. Thank you. Yeah, so what I was saying is to store these, what shall we do? This is the input lines for parallel, and this is the input line for serial. Like this is your serial input, and this is the parallel input. So you can store very easily 1, 0, 1, 1. So as you know like sent 1, 0, 1, 1, they would have gone here inside as 0, 1, 0, 0. So if you receive 0, 1, 0, 0, you have to consider that they have come as 1, 0, 1, 1 because they were not gated. Okay, so that is actually very easy to store in programming, so that you don't have to worry. But the thing is, just now you saw in parallel input there was no clock required. As soon as you load them, they will be already available. So there will be 0 clock pulses required. Okay. All right. because you can write it down. Those P1, P2, P3, those are called as, those are like Pn are called as preset input. Okay, preset. They are presetted. Okay, so this preset input don't require clock. Okay, or anyway, directly also if you load parallelly, they do not require clock. But this is very useful to keep with NOT gate, because they have some purpose. Let's take another question. Shall we solve shift register, a flip-flop question, and then we solve this question, or you don't want to solve any flip-flop question?
Sir, first flip-flop and then this.
Yeah, because flip-flop questions are actually...
Sir, I had a doubt there, like to get it says parallel input, serial output, right? Zero clock pulses for parallel input, but to get the serial output, you need again 3 clock pulses, right?
So, but it is not asking for the outputs, right?
Okay, it says to store. Okay, understood.
Yeah, it is just asking to store the output, store the values, how many clock pulses are required.
Okay.
Okay, why don't you do one thing? We will just, because questions are very big, I don't want to write it down. Huh? What, shall we put it directly?
Yes, sir.
Yes, sir.
Okay, so I'll just put it directly, okay? And I'll share you this file, okay? It will be easier for you to understand. Okay, let us take up one question. The question is, in the given figure, so this figure I had told you yesterday very easily, okay? So in this given figure, A is equal to 1, B is equal to 1. The inputs B is now replaced by a sequence of 1, 0, 1, 0, 1, 0 like that, okay? The output X and Y will be. So X and Y will be what? That is being asked, okay? You don't worry about the option, you just forget it. So this is the thing, okay? So you remember yesterday that I told you very clearly, where was it? This NAND gate was there, right? A, B, A, B, A, B, A, B. So as you can see in the NAND gate, this 0, 0 was 1, 1, that is invalid. 0, 1 was 1, 0, and 1, 0 was 0, 1, and 1, 1 was Qn and Qn bar, that was hold. Okay. So this was the configuration that was there. Same configuration is being asked here. Okay. So I'm not going to explain you how it had come. Yesterday I had explained you how it had come. Okay. So let's talk directly. I have written here A, B, Qn, Qn bar. Okay. Now let's see. What this guy is saying, A equal to 1, B equal to 1. It means what? Which is the configuration that is there with us? This
invalid.
One. Yeah, no, not invalid one. 1, 1, right? So
hold state, sir. Yeah, hold.
Yeah, hold state, right? So hold state can be anything. Let us assume that Qn is equal to 0 and Qn bar is equal to 1. Previously, right? So Qn plus 1 and Qn bar plus 1 will be hold state. So let's say at 1, 1, okay, my state is 0, 1, okay? So my state is 0, 1, that's all done, isn't it? So this is like, let's say, my previous state. Now, what I'm going to do, I am going to replace B is now replaced by a sequence of 1, 0, 1, 0, 1, 0 like that. So now it is 1, so it would become 0. So make it 0. So 1, 0 has come in the input. 1, 0 has come in the input. 1, 0. What will happen? You guys already know that 0, definitely the output will be 1. Definitely the output will be 1. And I mean, you know, like 1, 1, it will become 0. So 0 again it is. 1, 0, you can see here also 1, 0, the output is 0, 1. So 0. Then again 0 became 1 because B is only getting replaced. Okay, A is not getting replaced. A is as it is fixed 1, 1, 1 in all the. So 1, 1. So what is 1, 1? Hold state. So previous state will be hold like 0, 1. That's it. Now you may have a question that why don't we keep A, B and X, Y? My hold state is 1, 0. Okay, in the beginning, right? So 1, 0. Sorry, 1, 1. This is the startup. It has, you know, like earlier value 1, 0 instead of 0, 1. So now I am going to make 1, 0. What will happen? In 1, 0, my state will become 0, 1. Yes or no?
Yes, sir.
My state will become 0, 1. Now again, I'm going to make 1, 1. Right? So 1, 1, it will hold the previous state. So previous state is what? Tell me. Previous state is this one.
0, 1.
0, 1. So actually, whether you keep in the initial value 1, 0 or 0, 1, that doesn't matter. Okay, that's what I was trying to tell you yesterday also while teaching you the you know, like initial state of a flip flop. Okay, so so it can be assumed whether 0 or 1, 1 or 0, that doesn't matter. Ultimately, your output will be fixed based on the inputs. Okay, so it is always held constant with x equal to 0, y equal to 1. So you can write down fix at 0 and 1 respectively. Got it?
Yes.
Yeah. Same NAND gate, you know, like flip flop is given, and it is saying the unstable state corresponds to what? So unstable state was what? You remember? Unstable wave state was 0, 0, right? So you can immediately write unstable state is x equal to 0, y equal to also 0. That's all. Okay. If you want, you can keep this table handy. Okay, like can put it for you. Okay, so this table handy, so it will be easier for you to understand for different. See, in one of the figure, if I try making 0, 1, 0, 1, 0, 1, all the 4 inputs, right, and all the 4 B inputs, it becomes little bit, you know, like complicated. That's why I put 4 figures so that it is easier for you to analyze in all the 4 pairs what is the output. Okay.